Chapter 4, we start discussing rational functions. The definition of a rational function, which I'm going to call r sub x, is any function that I can write in the form of n sub x, make that a capital, make all of these capitals, over d sub x, where these two functions, n and d, are polynomial functions. Polynomial. And d of x is not the zero polynomial function. It's okay to get some zero. It won't be okay to get zeros in here. We're going to figure out what that means, but this cannot be identically equal to 0. For example, a polynomial over 0 is not a rational function. The simplest rational function that we know is one of our memorized graphs from high school algebra. It's 1 over x, where 1 is the polynomial function 1 times x to the 0th, and our denominator is 1 times x to the first plus 0 times x to the 0th. So we should recall from our high school algebra class and earlier when we talked about functions that the graph of this function looks like this, where when x is 0, I have what is called a vertical asymptote. And then as x gets very, very big, I am approaching 0. And when x gets very, very small, I'm approaching 0. And because it's approaching a constant number as x's get big and x's get small, we call those horizontal asymptotes. So we are going to need to be able to describe the behavior of a graph as it approaches its vertical asymptotes, and we're going to need to describe the behavior of the graph as it approaches, x approaches negative infinity and positive infinity. Again, in behavior. So in behavior of a rational function, well, if it's like this one, 1 over x, we get to a horizontal asymptote. Other examples of in behaviors of rational functions, I'm just going to put up a graph of a rational function, which we will see some examples of later. So here is a graph of a possible rational function. Notice here, my in behavior doesn't go to a horizontal asymptote. There are going to be some cases where I have, if I would have drawn it better, what are called oblique asymptotes. There are going to be other cases of my graphs of rational functions that I may not necessarily have a vertical asymptote, but I could end up with holes in my graph. And here, my in behavior doesn't approach a horizontal asymptote or a slant or oblique asymptote. It goes up without bound, or it can go down without bound. And we're going to figure out what forms of rational functions give us these different types of graphs. So again, the definition of a rational function is a function whose numerators and denominators are both polynomial functions, where the denominator is not the 0 polynomial function.